Well, welcome to St. Patrick's Day 2023, March the 17th. Ask Your Herb Doctor, KMUD Live, Garberville 91.1 FM. My name's Andrew May.
My name's Sarah Johannesson Murray.
So you're listening to Ask Your Herb Doctor on KMUD Garberville 91.1 FM and on the web at kmud.org. We're also live streaming this program on our Western Botanical Medicine YouTube channel. So you can listen live right now on our channel by searching Western Botanical Medicine in the search bar on the YouTube bar or by clicking on the live stream. So tonight's radio show is part 3, continuation of the endocrine hormone system and herbal medicines that can be used to treat it. My name's Andrew Murray.
My name's Sarah Johannesson Murray. Thank you for joining us.
We're both licensed medical herbalists who consult with clients with a wide range of conditions, and our website is www.westernbotanicalmedicine.com. You can also visit our site to see a list of our organic medicinal herb tinctures, and our contact details are there also. Alternatively, we can be reached on our toll-free number 1-888-WBM-HERB. Our Western Botanical Medicine's Twitter account's handle is @WBMHerb, and our YouTube channel is Western Botanical Medicine. Links to both our Twitter and YouTube channel are also on our website at westernbotanicalmedicine.com. So you're listening to Ask Your Herb Doctor, and we're going to carry on with part 3 of what we were doing the last 2 months, January and February, as a kind of discourse on the endocrine system. I want to start this show by saying, as above, so below. I was doing some work today to produce a show, reading some pretty interesting articles, things that we haven't really talked about, and I think some of the things probably weren't very attractive at times, I think, perhaps. But anyway, so like I said, as above, so below. And interestingly enough, St. John's wort is one of those herbs that we are going to look at somewhat, and with good cause, I think, given the paper and the discourse on melatonin. So that's going to be somewhat part of the back end of the show, but we're going to carry on so far as the endocrine system is concerned, where we left off last week. That was pretty much kind of beginning up in growth hormone, but just to round up what we had said about Vitex and luteal phase deficiency in females, as well as polycystic ovary syndrome, and all of the attendant problems associated with that dysfunctional physiology from an endocrine hormone perspective, that herbal medicine is very well suited to treat endocrine disruptants, just because herbs contain phytochemicals, and these phytochemicals can work at very, very low concentrations to affect change. And we've mentioned things like progesterone, estrogen, affecting change within the physiology of females at picogram levels. So extremely low concentrations are secreted by these organs to affect changes in target tissues. And herbal medicine can have very pronounced effects on the endocrine system by such a mechanism as that which progesterone and estrogen would affect change physiologically. So as women are very acutely aware, the menstrual cycle is a pretty cataclysmic time. And these hormones that affect these changes, like I said, they're picogram per mil concentration events. And just to define a picogram, it's a 10 to the minus 9, no, 10 to the minus 12. So you have nanogram and picogram, and progesterone and estrogen are measured both in nanograms and picograms, respectively. So these things are really very, very small concentrations. So just to say that the nervous system and the endocrine systems are operated and changed and checked and balanced by extremely low concentrations of these products in the bloodstream. So just to carry on last week's and to finish up with the perspective of a male's effect, things like horny goatweed and Tribulus terrestris, saw palmetto, and the ginsengs are all very positive for improving testosterone in the male. And testosterone has an extremely protective effect. Very much in the same way that progesterone will mitigate the damaging effects of estrogen, testosterone will work the same way. And fortunately for males, they're not stopped midlife with menopause, which brings a woman's progesterone production to an end. Males, as long as they've got a relatively good muscle mass, and that's why exercise, weight-bearing exercise, is so important. So long as they've got a good muscle mass, one brings the other. So muscles will support testosterone production, and testosterone production will support muscle growth. So,
but what I think you were getting at is that testosterone is so anti-aging for the man.
Yeah, absolutely.
And even in women who have higher testosterone levels, they also have extended lifespans because usually women who have higher testosterone levels are deficient in progesterone, and their body compensates sometimes with polycystic ovarian syndrome, for example, when their ovaries are not producing the proper or the correct amount of progesterone. The body can compensate by producing testosterone to protect against the damaging effects of the estrogen that's already present in the female. And so testosterone has a wonderful effect on longevity.
Also, just wanted to say, it is a live show, so from 7:30, I should have mentioned this at the beginning, but from 7:30 until 8 o'clock, the phone lines will be open, and we welcome any callers with questions either related to this month's subject or any other questions based on health and alternative medicine. So the number's 707 923 3911. So from 7:30 till the end of the show, 8 o'clock, if you'd like to call, just phone 707 923 3911 and pitch your question. So to carry on this part 3 endocrine discourse, growth hormone is the next thing we wanted to cover. So we're going to go through the last part of this growth hormone, adrenocorticotropic hormone, that and testing and its relationship to cortisol, etc. And then we're going to just go on to that's a posterior pituitary, the last part of the posterior pituitary. Then we're going to quickly go on to the anterior pituitary hormones, and then we're going to get into melatonin. So let's carry on with growth hormone. So growth hormone, also known as somatotropin, known as human growth hormone in its human form, is a peptide hormone that stimulates cell growth, cell reproduction, cell regeneration in humans and other animals. As its name implies, scientists originally found it to be responsible for growth and regulating growth during childhood. However, research has determined that human growth hormone is also responsible for the regulation of many of the body's other basal metabolic functions and operates as an acute phase stress reactant. Now, we've mentioned basal metabolic functions from a perspective of measuring your temperature and pulses and seeing what they are doing in relation to the glucose that you're absorbing from the food that you eat. So when you measure your body temperature before you eat and you measure your temperature after, that fluctuation should be a positive increase in both temperature and pulse. And that shows that your basal metabolic rate is being affected by glucose and not being orchestrated by stress hormones, because your temperature typically would fall a little and or your pulse.
Yeah, so if you're someone that feels cold after you eat, that's usually because the adrenaline was keeping you warm. And when you eat, you lower that adrenaline and then you get feelings of coldness and tiredness.
Okay, so human growth hormones production is tightly regulated through several complex feedback mechanisms in response to stress, exercise, nutrition, sleep, and growth hormone itself. The primary regulation factors are growth hormone releasing hormone. And this is produced in the hypothalamus, which is situated on top of the pituitary. Okay, and then also somatostatin itself is produced in various tissues throughout the body, and ghrelin, which is another component we've mentioned before, which is produced in the GI tract. So growth hormone releasing hormone functions to promote human growth hormone production and release. And in general, human growth hormone levels will be increased in childhood. They get to their highest levels during puberty and subsequently decrease with age. So one can think of the effects of human growth hormone as a combined effect of both human growth hormone and insulin-like growth factor. Now, human growth hormone impacts metabolism primarily by upregulating the production of insulin-like growth factor 1 and its subsequent effect on the peripheral cells. And additionally, human growth hormone suppresses the ability of insulin to stimulate the uptake of glucose in peripheral tissues and causes an increased rate of gluconeogenesis in the liver, leading to an overall hyperglycemic state. Many articles have shown the relationship between hyperglycemia and protective effects, and I'm not talking about over full-blown diabetes where blood glucose could be extremely elevated or the A1C extremely elevated, but that situations where the body's blood supply becomes richly um, richly high in glucose can be very protective. I think from a short-term mechanism of protection, that's one of the body's kind of emergency responses.
Well, there was that study that showed in care homes where people had an HbA1c of right on the borderline of what traditional labs call high. So, like between about 6.5. The study showed that people who had an HbA1c, which is showing long-term sugar control. So people that have a slightly higher HbA1c shows that their tissues are being exposed to higher glucose levels, higher sugar levels for extended periods of time. And the people in those care homes that had that level, this was, I think, out of the British Lancet medical journal, had less dementia and less degenerative disease. So they've already proven that exposing to slightly elevated blood sugar levels helps protect the brain.
Okay, and then I think just to cover the next anterior pituitary hormone that will lead up towards covering adrenocorticotropic hormone and thyroid stimulating hormone, prolactin. We have already somewhat covered it. Prolactin is also known as lactotropin. It's a protein best known for its role in enabling mammals to produce milk. Higher than normal levels of prolactin in your blood can cause certain symptoms such as irregular periods, infertility, and erectile dysfunction in males. So it's not just a female hormone.
And this is because what elevated levels of prolactin can do is they can stimulate estrogen. And estrogen can interfere with the testosterone in the man and the progesterone in the woman because estrogen blocks the effects of progesterone and blocks the effects of testosterone. So that's why it can give you irregular periods and erectile dysfunction because of its stimulating effect on estrogen, which affects the progesterone and the testosterone in the man and the woman.
And then dopamine, a brain chemical, and estrogen control prolactin production and release of it from your pituitary gland. So adrenocorticotropic hormone, quite a mouthful, controls the production of another hormone called cortisol, which we've done plenty on in the past. Cortisol being a stress hormone. It's made by the adrenal glands. Now, an adrenocorticotropic hormone test is often done along with a cortisol blood test to diagnose disorders of the pituitary or adrenal glands, and these include Cushing's syndrome, a disorder in which the adrenal gland makes too much cortisol, may be caused by a tumor in the pituitary gland or the use of steroid medicines. And steroids are used to treat inflammation, as most people might recognize from asthma through to other skin disorders and other inflammatory diseases, but it can have side effects that alter cortisol levels. So Cushing's disease, a form of Cushing's syndrome. Cushing's disease is usually caused typically by non-cancerous tumor of the pituitary. This tumor makes too much adrenocorticotropic hormone and causes the adrenal glands to make too much cortisol. And then Addison's disease, a condition in which the adrenal gland doesn't make enough cortisol. And hypopituitarism, a disorder in which the pituitary gland does not make enough of some or all of its hormones. So some symptoms of too much cortisol, and people might be familiar with that because these are fairly common things that people see. I think especially with the epidemic of obesity and the ingestion of food products in the food supply that are extremely thyroid suppressive and or obesity causing by either energy decreasing activity through their thyroid suppression, or particularly the polyunsaturates that are in these food supplies that cause basically a slowing down of metabolism by themselves. So symptoms of too much cortisol then can include the following things like weight gain, uh, especially a build-up of fat in the shoulders. So you find this kind of almost a dowager hump that some people will have, and in the shoulder, the tissue of the shoulders, there'll be like fatty pads. Uh, Pink or purple stretch marks, people may have seen these too, on the abdomen. They can be on the abdomen, thighs, and or the breasts in some patients. And these striae, as they're called, pink or purple stretch marks, are a fairly typical symptom of excess cortisol. Now, skin that bruises easily is also another indicator, perhaps, of high cortisol. It's not the only thing, but it's usually capillary fragility because the bruising is, in fact, bleeding in the tissue, the extracellular space. And so capillaries themselves, if they're not retaining the blood, they can leak, and this can then cause that bruising that you see. So obviously things like rutin and those particularly endothelial strengthening substances useful for strengthening the capillaries. Increased body hair can be another symptom, muscle weakness, and then fatigue and acne are fairly similar, symptoms of this condition. And then you have the symptoms of too little cortisol. So this is going to be things like weight loss, nausea and vomiting, diarrhea, abdominal pain, dizziness, darkening of the skin with salt craving and fatigue. So these again symptoms of low cortisol. Okay, so just to quickly go over 4 instances that could be a kind of differential diagnosis. So a situation where somebody has a high adrenocorticotropic hormone level and high cortisol levels can determine perhaps a Cushing's disease diagnosis. And then you have the excess of low adrenocorticotropic hormone and high cortisol levels. This could be perhaps indicating Cushing's syndrome or a tumor of the adrenal gland. And then high adrenocorticotropic hormone and low cortisol levels could be Addison's disease, and low adrenocorticotropic hormone and low cortisol levels can be from hypopituitarism. So, Sarah, did you want to say anything about?
Yeah, so I just wanted to mention the herbs and supplements that can help affect the high cortisol state that you're mentioning here. Obviously, a very serious form of very high cortisol is the Cushing's, but in a more moderate degree where it might not have been properly diagnosed as Cushing's, there's lots of herbs that can affect and modulate that high cortisol level. Licorice is definitely a very useful herb in helping to modulate the cortisol levels. And a lot of times people can have high cortisol levels just from stress because the stress stimulates adrenaline, the adrenaline stimulates cortisol, and it's a backup mechanism to keep the body functioning, but it can have long-term detrimental effects. And so taking adaptogen adrenal herbs are very useful in times of stress to keep the cortisol and adrenaline in check. Other herbs are like the different ginsengs, the eleutherococcus, those also modulate the adrenal glands. And pregnenolone is a supplement that will actually help turn off the brain's production or downregulate, let's say that, let's modulate and balance the brain's production of cortisol through interacting with ACTH, which is the brain hormone that stimulates cortisol from the adrenal glands. So those are a few supplements that can help modulate stress because cortisol is a stress hormone.
Okay, you're listening to Ask Your Herb Doctor, KMED, Garberville 91.1 FM from 7:30 till the end of the show. You're invited to call in. The number here is 707-923-3911. Okay, so just to quickly get onto TSH, we won't do too much on it. We've spent quite a long time over many years, I think, talking about thyroid stimulating hormone, but just basically to say it's one of those other anterior pituitary hormones, which needs mentioning just because it's one of the last ones. Okay, and then we'll get into the posterior pituitary hormones and then go on from there to melatonin. So,
well, just a little side note there, Andrew, about TSH and thyroid, since that has been quite the popular topic on our shows. But if your basic metabolism is not working, then the backup mechanism for your body is stress hormones. So if your thyroid activation in your liver is not happening, then your brain senses that, raises the TSH, and tries to get your thyroid gland to stimulate more thyroid hormone. It's really the cell's fuel. It has to have thyroid hormone, active thyroid hormone that gets converted in the liver in order to utilize oxygen. It's the fuel for our body. So when you move on to talking about TSH as one of these hormones, it's really a base hormone that we have to have in order for all the other hormones to operate properly.
Okay, so the hypothalamus then, as I said, is superior to the pituitary. So if you imagine in the middle of your brain an organ that is basically has two small organs dangling from it. So the hypothalamus essentially is superior and the anterior and posterior pituitary are below it. So the hypothalamus in the base of the brain produces thyrotropin releasing hormone, and thyrotropin releasing hormone stimulates the anterior pituitary gland to produce thyroid stimulating hormone. The engineer's laughing. What are you laughing at?
Your mic technique. You should
put
your head above your microphone and look down in your lap and read.
Secure the microphone for me, please. There you go. All right. So, as I said, then thyroid stimulating hormone is secreted from the anterior pituitary in response to detected levels of circulating T4. And then we mentioned T4, which is a weakly active physiological hormone, but which in turn is used to synthesize the physiologically active form of thyroid hormone, T3.
So that's the conversion in the liver I mentioned earlier. The T4 most of the gland produces T4, which goes to the liver and gets converted into T3, the active form. And that's also a site where a lot of different foods can interfere with the conversion, and sugar levels can interfere with that, and stress hormones can interfere. So that's a really critical part where we can influence our thyroid levels and our basic metabolic rate by what we eat, because it affects our liver, and our liver has to do that conversion. Our gland does produce a little bit of the active thyroid hormone, but not enough. We have to rely on our liver to convert it.
Okay, so basal metabolic rate, as we've mentioned, is a kind of standard indicator of activity within the organism, and basic metabolic rate is measured by body temperature. And as we've mentioned before, it's tightly constrained, just like pH is, within a very narrow range, outside of which negative effects occur. So it's tightly controlled, just like pH. And it's best determined not with a TSH test, which is standard medical procedure, but by the use of basal metabolic rate in conjunction with temperature and pulse rate before and after eating a meal. So we've done many radio shows with Ray Pete about this seeming incongruity with the medical establishment's doctrine of this erroneous blood test to assess thyroid function. And listeners should review the shows posted on our website at westernbotanicalmedicine.com on the resources link. As I mentioned earlier too, we are in the process of uploading all the shows to our newly created YouTube page at youtube.com at Western Botanical Medicine. So slowly but surely, they will get put there. But okay, so I think from an herb perspective, one of the best known herbs used for hyperthyroidism, which I think probably in terms of what I've seen in the last 12 years, at least here, is actually not very common. But I see way more people with low thyroid states than hyperthyroidism. But one of the best known herbs used to treat this, especially in Europe, and that's part of its name, is Lycopus europaeus, known as gypsywort. Now, it inhibits iodine conversion in the thyroid gland. It's used to treat hyperthyroidism and for some symptoms of grave disease, such as palpitations. And an article from the Journal of Pharmacy, Volume 9, Issue 7, Series 1, written July 2019, mentioned the extracts of Lycopus europaeus reduced the weight of the thyroid, decreased thyroid hormone activity, and increased absorption and storage of iodine in rats. And the extract retarded goiter formation, which is the basic swelling of the thyroid gland in response, in propylthiouracil treated rats. So all animals treated with the extract showed reduced metabolism. So this was actively showing it was slowing their metabolism.
And just like a little side note here on that drug, the thiouracil drug that is used to treat hyperthyroidism, so that's too much thyroid in the blood, that drug is almost identical to cabbage juice. So I know it is St. Patrick's Day today, so we can't speak ill.
Does cabbage juice have some of the similar activities?
Yes, it has almost exactly the same compound. And if someone had overdosed on thyroid, for example, a child, you can juice cabbage and feed them that. That's the same. It's basically the same drug as the propylthiouracil to block the thyroid hormone uptake. So that's another point too. You don't want to eat too much cabbage
if you have low
thyroid.
Well,
in general, you don't want to eat.
Too?
Yeah, all of the brassicas, you don't want to eat. I love them, but you don't want to eat them every day, 3 times a day, or juice them raw, because you will be interfering with your thyroid hormone production, which is so important because that's your basic metabolism.
My sister lives in Korea and has a bad thyroid, so I'm going to tell her that right now.
She's probably eating it fermented, which it does help reduce some of the thyroid blocking.
Okay.
And cooking it a long time, like if you boil your kale for an hour.
But kimchi has less.
Anything fermented and cooked a long time has a lot. It reduces the activity of that thiouracil, which is the thyroid blocking compound.
Probably those people that eat a lot of borscht would do well to listen. Okay. High doses of Lycopus reduced TSH, thyroid stimulating hormone, and thyroid hormone levels in animal experiments. And hyperthyroid patients treated with low dose Lycopus europaeus showed improvement of cardiac symptoms without major changes in TSH or thyroid hormone concentrations. Wanted to mention, so when thyroid stimulating hormone binds to the outer membrane of thyroid cells, it triggers a cyclic AMP response on the inside of the cell via a component called adenylate cyclase, which is an enzyme activation. Rosmarinic acid, on the other hand, here, the major compound isolated from this extract contained rosmarinic acid, and this decreased the TSH stimulation of thyroid cells via inhibiting the same process, adenylate cyclase. And rosmarinic acid also was noted to inhibit the degradation of the iodine processing and inhibited the conversion of T4 to T3. So a little bit of an aside there. I really have need to use it. I see more people for sure. You come across way more people with low thyroid than hyperthyroidism. But anyway, it's
also
europaeus.
What gets diagnosed as hyperthyroidism or high thyroid is a high level of T4. And that can be purely because of a poor liver function, not converting the T4 into T3. And so when someone presents with high T4 levels, you really need to dig into why their body is not converting that. And if you correct their metabolism, their liver metabolism, and clean their diet up from all the thyroid suppressive things that could be blocking that conversion, you can remedy the high T4, because it might not really be their gland is producing a lot of T4. It just might be that their liver is not converting that T4 into T3. So really they are actually low thyroid. When you have a high T4, you're actually low thyroid because you're not getting enough active. The T4 has no physiological effect. It has to be converted in order to affect metabolism and help your cells utilize oxygen better. And that will not happen unless T4 gets converted into T3.
Okay, so for posterior pituitary hormones and their targets, we turn to oxytocin. Okay, and it's 7:32 here, so if people want to call in with any questions, oh, don't we have one? But the number here is 707-923-3911. So folks, if you want to ask questions about this show or you want to ask questions about other health-related topics, 707-923-3911. So let's take this first caller. Caller, you're on the air. Where are you from, and what's your question?
Is that myself?
Yes. Where are you from? What's your question?
Oh, awesome. No, I live in Redway.
Okay.
I used to live up on the east side, up on the mountain.
Okay.
I found through my, I guess, I don't know if I'm saying it right, a dietologist. I go for all my medical stuff at Gerald Phelps Hospital in Garberville.
Mm-hmm.
So my doctor is pretty knowledgeable about diet and stuff.
Mm-hmm.
So instead of me taking pills to help me sleep, I've been eating like salads like with my meals for dinner. So I'll eat a lot of romaine lettuce, or I'll have kale, and then like maybe some cottage cheese, but I'll kind of spit it up with a little bit of pineapple, in a can.
Mm-hmm.
But I guess I don't know how calcium helps you sleep, but it works great for me. And people, I've actually, after my doctor had said this, I kind of was like skeptical myself. So I kind of Googled it, and it was all right there. Google. And then for cortisol, I eat a lot of kale and bananas and avocados and a lot of dark greens. And supposedly that's good for at least reducing or keeping it away from you if you don't have it. I'm 66 years old, but for my age, I was already told by my doctor that I'm pretty prime. And she's like, you're almost a rarity. But I'm from Danish ascent from Denmark during and after World War II. So my family and my genes don't have a whole lot of the American diet that has been accumulated through families passed down from the 1800s. If you're around in this area from the 1800s,
Sure.
I don't have that.
Well, what you mentioned about the calcium and helping you relax. Calcium is much more
Hello?
than your bone health and your
Hello?
teeth. Hi, can you hear me?
I hope I didn't lose you. I wanted to ask a question. I'll try calling back. I can't hear you.
So basically, calcium, it affects so many different physiological systems in the body. And you mentioned that calcium helps you sleep. And that is true. My mom always said that she needs to make sure she has a glass of milk before she goes to bed. And it's not just the little bit of lactose in there that helps her go to sleep. The calcium, it not only feeds good bowel bacteria, actual calcium promotes good bowel bacteria. It's a relaxant. It blocks stress hormones. Parathyroid hormone gets blocked by calcium, and parathyroid hormone stimulates a lot of other stress hormones. There's antidiuretic hormone that plays into it as well. So there's a lot of different factors and anti-aging, anti-inflammatory effects that calcium has.
I wonder about the kale. I know that the brassicas typically, to eat a lot of brassicas, they do contain thyroid suppressive compounds in them. So I'm not too sure about that. But for sure, from a sugar perspective, the sugar is certainly part and parcel of getting the cells to relax, restoring energy, and shutting down adrenaline.
And also lettuce, if you aren't allergic to lettuce fiber, or your bowels can cope with the fiber from lettuce and you don't have any bad reactions to it, because it does stimulate some inflammation and serotonin. But lettuce itself has some sleep-inducing effects as well. And the kale, I love kale. Like I mentioned earlier, it's not good to eat it every day, and it's better to eat it cooked so you can absorb the minerals that are in there. But the minerals, the calcium and the magnesium, those are also relaxing and can help your muscles relax so you can go to sleep.
Did the caller call back with a question, or is he?
He hasn't called back. And
no
just as a note, people are having a lot of trouble hearing when you call in, and I'm sorry. Supposedly we're getting a new board, but I've heard that for years.
All right. The number here is 707-923-3911. Go ahead and call in. We'd love to hear your questions. We'll carry on. And so oxytocin, we're going to talk about posterior pituitary hormones. Let's quickly get through this. I just want to get to melatonin because I found some really pretty exciting research. Okay, so oxytocin then, the natural hormone, stimulates uterine contractions in childbirth and lactation after childbirth. So it's not just for uterine contractions, but it also affects aspects of human behavior in the male and female reproductive systems. And the two main physical functions of oxytocin are to stimulate uterine contractions in labor and childbirth, and to stimulate contractions of breast tissue to aid in lactation after childbirth. But oxytocin also acts as a chemical messenger in your brain, and they found that it has important roles in many human behaviors and social interactions, including sexual arousal, recognition, trust, romantic attachment, parent-infant bonding. So it's a kind of love, kind of feel good hormone. So oxytocin's involved in addiction, anorexia, anxiety, autism spectrum disorder, depression, and post-traumatic stress is also being investigated. So during labor, when the fetus's body, usually the head or hopefully the head, pushes against the cervix, the nerve impulses from this stimulation travels to your brain, stimulates your pituitary gland to release oxytocin into your bloodstream. This then travels to the uterus and stimulates contractions. And these contractions in turn cause your pituitary gland to release more oxytocin, leading to an increase both the intensity and frequency of contractions. So oxytocin also increases the production of prostaglandins, which are not particularly good. They're kind of group of lipids with hormone-like actions. They're typically involved in inflammation, but the prostaglandins are shown to be responsible for moving labor along and increasing the contractions through their inflammatory effect even more. This enables you to carry out regular delivery. Okay, so not too much more to say about that. Let's get on to melatonin. So essentially, that is the anterior posterior pituitary axis with the hypothalamus, all of the target organs, some of those herbs that will affect that change in it. And then I wanted to get to the the pineal gland. So I guess we should probably, let me just quickly get to that. If we need to, I'll rewind to some more information about antidiuretic hormone, but I really want to make sure that we get to the end of the show having covered everything that I read when I was putting this together here for the pineal gland. It's really not talked about too much, I don't think. I know certainly from a perspective of serotonin and melatonin, they're just like buzzwords, and I think the production and consumption of these things has probably skyrocketed. Another one of those bumper bonanza products for the supplements industry. I think Dr. P had quite a bit of reservation, obviously, and we talked about serotonin's activity and production in the gut leading to inflammation. We've mentioned tryptophan and the amino acids derivation of these substances, and also like I said, Dr. Pete was never really wasn't really enamored with serotonin. Neither was he that enamored with melatonin. But I read a really interesting research article that I don't think was funded by a drug company producing melatonin, but there was lots of different references for the effects of which had been studied, and it seemed to show some really conclusively positive results that were brought out by the whole study. So
I remember Dr. Pete telling me that melatonin, if used in the short term to get over a chronic, to get over an acute problem, not to use chronically, was safe enough. But he obviously, like any supplement, you don't want to have to live on a supplement. You want to correct the problem and move on without it. So I think that was the basis for a lot of his recommendations. So it wasn't that he was completely against melatonin. He just didn't want people to rely on that instead of trying to figure out why their bodies weren't producing enough or why they were having to use that to get to sleep.
okay,
What other reasons were causing their insomnia?
So the main function then of the pineal gland is to receive information about the state of light to dark. It's a cyclic circadian gland that regulates our sleep patterns, our wakefulness or sleepfulness. But more than that, there's so much more going on. So basically, this is information from our environment, and it conveys this information by the production and secretion of the hormone melatonin. So in all organisms, the primary function of melatonin is to act as a free radicals scavenger and reactive oxygen species detoxifying agent. So it's majorly important for the antioxidant system. So bear that in mind first. So these reactive oxygen species are highly generated during the aerobic metabolism, mainly in mitochondria and chloroplasts in plants. Thus, has been hypothesized that these organelles are sites of melatonin biosynthesis in plants. Now, regarding melatonin biosynthetic pathways, they're similar between animals, humans, and plants. And briefly, they consist of the same precursor, tryptophan, which we've mentioned in the past. And turkey obviously is one of those kind of high tryptophan foods. And the whole rationale between eating a turkey dinner and feeling very tired and sedate. And two common derivatives. So basically, the precursor tryptophan and two common derivatives, serotonin and N-acetyl serotonin. However, the tryptophan conversion to serotonin in animals occurs via 5-hydroxytryptophan, whereas in plants it occurs via tryptamine. And probably those people out there who are plant lovers would probably recognize tryptamine, diethyltryptamine, and other what do you want to call them, entheogens, perhaps. In the latter, serotonin can be converted into melatonin via N-acetyl serotonin, as in animals, and 5-methoxytryptamine. In all organisms, the primary function of melatonin is to act as a free radical scavenger and, as I mentioned, a reactive oxygen species detoxifying agent. So, two herbs, and I didn't even know. I'd never really considered it much because we'd never really talked about melatonin. I think we've mentioned it a few times in passing. And yeah, like you said, I think Dr. Pete's rationale for it was that in very short terms, maybe it's an emergency thing, yeah, but he didn't really have too much good to say about it, I don't think. Otherwise, we would have done shows on it in the past. But essentially, there's two herbs that have melatonin levels that are sometimes higher than found in animals. And I wanted to bring this out from an alchemical perspective, that one of these plants is St. John's wort. Now, the other one is Tanacetum parthenium, or feverfew. Feverfew is in the compositae, and its little flower looks just like a sun, right? So the
It's like a little tiny daisy.
little tiny daisy. Okay, so from let's get kind of out there with the alchemy and the astrology and all of the other interrelated things that I think have a lot of bearing in our lives. Not to say that they are the be all end all, obviously not. I think the divine creator has put all of these things in our path, that through them and through study we can find out way more than we see around us. Things are not as they seem, folks. And so these two plants, Tanacetum parthenium, feverfew, which is in the compositae, and St. John's wort, have levels of melatonin sometimes higher than found in animals. So now, as a structural analog of indole 3-acetic acid, commonly known as a rooting hormone for people that grow, a common auxin also derived from tryptophan, melatonin is involved in plant growth regulation and development, not surprisingly. Okay, so very similar in its structure to indole acetic acid. So this is a rooting hormone, okay? Now, indole acetic acid is commonly known as one of the many rooting hormones, as I said, used to promote root initiation in plant cutting material. Now, broadly, melatonin affects photosynthetic processes efficiently by the following: delaying chlorophyll's degradation, right? Plants need chlorophyll to convert sunlight into oxygen and sugars. And 2, by increasing CO2 uptake. And 3, accelerating the electron transport. Now, isn't this the same thing that in humans that we'd like to see more of? I know we don't contain chlorophyll, folks, but delaying those kind of beneficial components and substances that enable us to convert sugar into enable us to break down food into sugar so we can put it into the Krebs cycle so we can get energy from it, which is what chlorophyll is all about in plants. We'd like to increase our CO2. CO2 is very protective, and we would like to accelerate the electron transport. So besides its direct and indirect properties against oxidative damage, which is secondary to all abiotic and biotic stresses. Now, melatonin also stimulates a number of specific plant defenses at the proteomic and genetic levels against various stresses like cold, drought, high temperature, strong light, heavy metals, and pathogens, among others. So it's a plant defensive agent. Now, the amphiphilic nature of melatonin allows it to easily cross cellular and morphophysiological barriers, including the blood-brain barrier. So it moves around very easily. It's not inhibited by any of these structural or membranous borders that would typically keep out certain substances. Now, melatonin has been shown to have actions such as amyloidogenic, right? So people that have maybe have relatives with neurodegenerative disease and the kind of neurofibrillary tangles that are associated with things like Parkinson's
and Alzheimer's.
and Alzheimer's, right? So think about that for a moment while you're listening. So melatonin crosses the blood-brain barrier and has been shown to have anti-amyloid activity, especially in the brains of Alzheimer's patients and other neurodegenerative disease patients. So, as an endogenous indolamine, melatonin has huge physiological functions, including regulation of the sleep promotion, circadian rhythms, as we mentioned, mood, immunomodulatory actions, neuroprotective effects, bone growth effects, hormonal regulation, tumor suppression, defense against oxidative stress, and anti-inflammatory activity. Moreover, melatonin is effective in treating periodontitis, mucositis, and even some cancers. Now, melatonin has promising anti-neoplastic potential owing to its anti-proliferative, basically stops things from proliferating or over-proliferating like tumors would.
Anti-cancer.
Cytostatic, so it'll hold cells in a certain stage of development. So this is, again, a kind of cell cycle hyper activity of cancers. Anti-metastatic and pro-apoptotic effects, so against tumor cells specifically. So it will actually pro-apoptosize tumor cells. So it'll actually enable them to go into their programmed cell death rather than avoiding it like they do and carry on proliferating. So melatonin has promising anti-neoplastic potential owing to its, as I said, anti-proliferative, cytostatic, anti-metastatic, and pro-apoptotic effects against tumor cells. And melatonin may also be beneficial in the treatment of dopamine-related disorders. Evidence suggests that it modulates dopaminergic pathways involved in the coordination of body movement disorders in humans. So now this is part of Parkinson's. In terms of the effects on the motor system through this dopaminergic pathway, this is something here that could well be valuable. So just keep all these things in your mind, and we'll kind of try to join them up at the end. So melatonin protects the brain via the immune system, and as a defense against reactive oxygen species and this damage that it causes, it has beneficial effects against mitochondrial dysfunction, considered a major causative agent in neurodegenerative disease, such as Alzheimer's, Huntington's, and Parkinson's. Now, some studies indicate that melatonin in the range of 50 to 100 milligrams per day is effective in reducing oxidative mitochondrial dysfunction in experimental models of these diseases, Alzheimer's, Huntington's, and Parkinson's. It's equally effective in vitro and in vivo in preventing oxidative nitrosative stress-induced mitochondrial dysfunction. So it's extremely antioxidant. And again, with this, if you look up the physiological concentrations of melatonin, it's actually very small. So I was kind of surprised to see the dose of 50 to 100 milligrams per day, but that's possibly because it's rapidly broken down. It's secreted all during the nighttime. It's all part and parcel of initiating sleep, initiating that kind of relaxation. But essentially, it's broken down very quickly. So as it's produced, it's more or less rapidly degraded again. Now, Lipid peroxidation, which we spent many shows talking about, and the damaging effects of lipid peroxidation, as well as the reactive oxygen species generation in neurons, also leads to neuropsychiatric and neurodegenerative disorders. So thus, because of the strong antioxidant activity and diverse pleiotropic actions of melatonin working on so many different levels, it's been proposed an effective neuroprotective agent in diverse neuropsychiatric disorders. So recently, melatonin has been produced as a potent mitochondrial protector. Indeed, melatonin was detected at higher concentrations in mitochondria than in other organelles or subcellular compartments. And to highlight that, mitochondria comprise the major cellular sites of reactive oxygen species production during respiration and ATP synthesis, which is all part and parcel of our energy production. So in addition, high levels of melatonin are accumulated in these organelles against a concentration gradient by mitochondrial membrane transporters. And not least important to highlight is that according to the endosymbiotic theory on the origin of mitochondria from melatonin-producing bacteria, these organelles likely evolutionarily inherited the capacity to synthesize melatonin. Therefore, as recently reported in excellent reviews, melatonin can scavenge these reactive oxygen species, decreasing mitochondrial oxidative damage, now consequently preserving their structural and functional integrity, and finally delaying cellular aging and the onset of age-related disorders. So this is all part and parcel of the antioxidative effects and the damaging effects of oxidation that occur when there is any deficiency of these substances that are antioxidant. So consider the role between sleep disturbances, periodontal disease, low thyroid physiology, depressed energy production, mitochondrial inadequacy, low testosterone, and Parkinson's disease formation. And you'll see this substance along with herbs like St. John's wort as examples of treatment strategies. So, as I mentioned at the beginning of the show, as above, so below. These things are all around us, and it just takes the eye that beholds and the ear that hears to go forward. Okay, so we have a caller. Now let's take this caller. Caller, you're on the air. Where are you from? What's your question?
Here.
Hello.
Caller, you're on the air.
Hi. Hi, my name's Adrienne from Blue Lake, and I just wanted to say about the St. John's wort. I have Lyme's disease, and I have fresh St. John's wort here that I've made into oil, and it's helped my nervous system so much. I've read that it is specific for sciatica, for nervous sciatica. Also, I wanted to say that I got a second-degree burn on the heel of my thumb, on the base of my thumb, from a 500-degree thing, and I thought I would be incapacitated for work, but I applied the fresh St. John's wort oil, the fresh St. John's wort flower oil to that burn. It was the entire heel of my thumb, and instead of turning into a blister that I wouldn't be able to work through because I'm a baker, it actually re-adhered to the skin. It was a 1.5-inch round burn, and it re-adhered, and after a week it gently flaked off, and there was no real injury. It was a miracle.
Cool.
I just wanted to tell people that.
Well, thank you for that.
For your show.
Yeah, you're welcome. Thank you for your call.
Thank you for sharing that. And just to let our listeners know, since we're almost at the end of the hour here, you can all make your own St. John's wort oil. It's very easy if you have access to St. John's wort flowers. It's also known as Klamath weed locally here because it grows along the Klamath River. They're yellow little flowers. It's traditional to harvest them around the summer solstice, June 21st. Sometimes they bloom a little earlier. Sometimes they bloom a little later. You pick the fresh flowers, just the flower, and you put it in olive oil and put that in the sun, and you'll make the most beautiful red oil that has all these neuroprotective effects topically. Internally, you would want to make a tincture of the flowers with vodka. You can use vodka. It's 40%. Soak as many flowers in there as you can. It's better to, if you're going to make the tincture, to dry the flowers first. But to make the oil, you need to use the fresh flowers. Set it in the sun for a month or more. Sometimes I let mine sit longer, and it will make the most beautiful red oil that has healing properties for topical use.
You also want to try and separate where you can the water content of
Yeah,
the
once
flowers.
you want to use the oil, you can press out the
We've used
oil, and
higher
you'll have
quality oils
a
too.
water portion that comes from the little bit of moisture that's in the flower.
I was surprised you said olive oil, because we've used much more.
Well, jojoba oil, but
Yeah.
it's just harder to come across.
Yeah. Okay. So yeah, ruled by the sun. Its solar signature. St. John's wort. There's plenty to say about it, and a great call from that caller. And one last thing, just to say that the oil is bright red, and this is the hypericin in the oil glands of the flower, and that red substance, as we've mentioned many times on many shows with Dr. Pete, anti-inflammatory, free radical quenching activity par excellence. So very good at quenching the inflammation. So that caller mentioning that burn, obviously a classic inflammation, some very good results from it. So excellent. Okay, well, let's just give the outro here in the last 2 minutes of the show before we step on the heels of the next DJ. So essentially, the third Friday of April, we'll be back. You've been listening to Ask Your Herb Doctor, KMD Garberville 91.1. This evening's show was the last part wrap-up, perhaps, of the endocrine system from a hypothalamic pituitary perspective. Next month, we'll cover some more endocrine organs and their effects and the herbs that can be used to treat and regulate those things. My name's Andrew Murray.
My name's Sarah Johannesson Murray.
We're both licensed medical herbalists who consult with clients about a wide range of conditions. Our website is westernbotanicalmedicine.com. You can visit the site and see a list of our organic tinctures or contact details, and we can be reached toll-free 1-888-WBM-HERB. And our Western Botanical Medicine Twitter account's handle is @WBM-HERB, and we'll be posting any future news, as I mentioned, regarding the family's efforts to preserve Raymond Pete's published and unpublished works for generations to come on our Twitter page. It goes slow. There's lots to do in the meantime. So please be patient and stay connected with us on Twitter. And we'll also be tweeting upcoming Ask Your Herb Doctor announcements and more. Links to both our Twitter and YouTube channels are also on our website. So until third Friday of April, happy St. Patrick's Day.
Thank you. Good night.